Okay, so this is fun to talk about transportability as part of a series, which is really cool. I'm going to talk about applying transportability to study the effect of a housing intervention. So this is the Moving to Opportunity study, so it's a little bit different, so we're not in, we're in a different land here, not in the HIV/AIDS land, but we're, oh, sorry. Okay, so the Moving to Opportunity experiment was a randomized trial conducted by the U.S. Department of Housing and Urban Development in the 1990s in 5 cities in the U.S., which I'm showing here. And families could sign up who lived in high-rise public housing to be randomized to either receive a Section 8 housing voucher or not. And we still have these Section 8 vouchers today. And what they do is they allow the families to move out of their public housing and into a rental on the private market. And then they followed these families up for 2 time points later on. It's a cool study because we talked a little bit about, one of the previous speakers talked about when we have an instrumental variable designs, and so that randomization to receive a voucher becomes an instrument for an exposure that we care about, a neighborhood exposure that we might care about. And so as an instrument, it can address both observed and unobserved confounding. Now, one of the puzzles of the Moving to Opportunity study is that the effects generally, they didn't always replicate across the sites. And so I'm showing an example of that here. So this is looking at marijuana use in boys at follow-up. And so this is risk of marijuana use. And then I'm showing 4 of the sites across the bottom. And so we see that for the Boston site, for example, being randomized to receive that voucher resulted in an increased risk of marijuana use, but we didn't see that same unintended harmful effect replicate in the other sites. We see pretty null results. And this is not frequently talked about. MTO literature is vast. There are hundreds and hundreds of articles written about MTO, but in general, this lack of replication across sites wasn't really talked about, except for it was documented in their progress reports. And so in discussing these differences, though, the researchers in these progress reports kind of threw their hands in the air and said, it's not possible to disentangle the underlying factors that might cause these differences across sites. So my goal was to see, well, can we use transportability to try and help us get a little bit of traction in understanding why these effects may differ? And so you've gotten a great introduction to this already, but transportability is the idea of applying the results of an experiment that was conducted in a source population to a new target population, accounting for differences in the population composition. And so in terms of MTO, it allows us to answer a question like, for example, in the New York City site, we see that MTO is associated with increased marijuana use in boys. We might ask, okay, well, what if we implemented this intervention in Boston? Would we expect to see the same result? And so accounting for the differences in the 2 populations, we might be able to predict, should we expect the same result or not? But to take a step back first, I think it makes a little bit more sense to think about how site was handled in general in these moving to opportunity analyses. So in general, it was used as a covariate to control for, and that's frequently, I think, what we do when we have a multi-site trial or study design. So that's like a fixed effect, and that usually assumes that we assume that the treatment effect in one site is the same as in another site. And so why is that? It's because when we think about a regression or something, a dummy variable for site is going to change the intercept of that regression, but it's not going to change the treatment effect coefficient. So that assumes that that conditional effect, that regression coefficient, is the same across the sites. And so we can ask ourselves, do we think that that's a reasonable assumption? Do we expect that an intervention effect in one site will be the same as an intervention effect in another site? And there might be a couple reasons why we might say no. So one is differences in context. So these could be differences in site-level variables that might modify intervention effectiveness, so like fidelity to the intervention design, or these like macroeconomic factors that might modify the intervention effect, the housing market, things like that. There could also be differences in person-level variables that modify intervention effectiveness, and so I'm going to call that composition. So in many cases, it really may not be reasonable to assume that the effects are going to be different for these different populations. Now, the vast majority of these hundreds and hundreds of papers use site as a fixed effect, but a few papers actually used site-specific effects. And that assumes that the effects, even the conditional ones, are different for every city. And so again, we can think about that in terms of regression, and that's because we are now interacting that treatment effect coefficient with site, with a dummy variable for site. Now what that means is that we can't actually learn anything about how the intervention will work in one city from how it worked in another city. Now both approaches seem pretty extreme to me. So moreover, neither is using evidence to inform decision. So you know, as a reminder, for the two approaches, one assumes the same effects in all the cities, the other one assumes different effects in all the cities. And it's really based on the investigator's opinion. Like, does the investigator think the effects should be all the same, or does the investigator think that they should all be different? So I think transportability is a third option that might offer some middle ground and might actually allow us to use the data as evidence for making a decision like this. So again, transportability in terms of MTO allows us to assess the extent to which differences across these sites can be reconciled by accounting for covariate differences across the sites. And I think in general it has some broad applications. So it allows us to get I think can be called personalized predictions for place. And so you know, the status quo currently is to kind of assume that, okay, we did the intervention over here, we're going to assume that it's going to work the same over here. Well, in this case, we can take all the differences that we know about these two places, these two populations, and say, actually, we might be able to do a little bit better. We might be able to be a little bit more accurate in our prediction in this new site. And I think it's also useful to predict long-term intervention effects in a new site based on the results in an original site. And so this might be useful because sometimes we're looking at outcomes that are not going to happen for decades later. And it can also be used for surrogacy in clinical trials. Now, we talked a little bit about this so far. Methods to do this are not new. And so Daniel talked about just simple reweighting, post-stratification, direct standardization. These have been around for so many decades, like more than 50 years. It's what we all learned when we took our first epi class about how to make age-adjusted rates of disease. There are also some selection model-based approaches, like model-based standardization, weighting, propensity score matching, principal stratification. Those are a little bit newer, and they allow us to now standardize based on a whole high-dimensional vector of covariates, continuous covariates, things of that nature. And then Perel and Berenbaum just pretty recently formalized the theory and assumptions underlying transportability. So our contribution was to develop estimators for transporting effects when we have an instrumental variable set up. So that involved a slight extension of Perel and Berenbaum's transport formula. And so because we were developing these estimators, we wanted them to have a couple different features, a couple positive features, so we could get inference based on theory, even when we're incorporating machine learning. And then they're doubly or multiply robust, which means that we can misspecify multiple models and still get consistent effect estimates. And so these estimators we made for this particular data generating mechanism that corresponds to the MTO intervention, where we have voucher receipt acting as an instrument that influences moving with the voucher out of public housing, which then ultimately we think influences adolescent substance use. And then we have site, and then we're accounting for these covariate differences by site, and we're also accounting for the fact that there might be different take-up by site too, that different sites may have different probabilities of actually using that voucher to move. And so we made targeted minimum loss-based estimators for several different types of effects that you could estimate in this scenario. I'm just going to show the results for the intent to treat, average treatment effect transported to the new population, just for the sake of time. So now we're going to apply our estimators to see if they can shed light on what was previously this intractable problem of not knowing why there are differences in effects across sites. So we're going to take two sites, LA and Boston, and we're going to use the outcome of adolescent school dropout at follow-up. We're going to use all the data from Boston. And for LA, we're going to pretend that we don't have the outcome data. So using the outcome model for Boston, we're going to predict the intervention effect in LA, accounting for these compositional differences between the two cities. So if our predicted effect equals the observed, then this means that the differences were largely due to composition. If it doesn't, it might suggest that the differences were largely due to context or due to some unmeasured compositional variables. So here are the results for Boston. So the risk difference is shown on the y-axis. So we see that being randomized to receive this voucher actually reduces the likelihood that kids drop out of school at follow-up. So we might want to know, okay, if we were to implement this in LA, would we expect the same protective effect? And using our method, the answer is no, we wouldn't expect it. We would actually expect no effect. So maybe if one had reduced resources, we might decide not to implement first in LA, maybe we would implement it in another city where we might expect a positive effect. So the test is here, we have the actual true data. We don't have to just rely on our predictions. So we can see, okay, using our observed data, how good of a job did our estimator do at predicting? And it actually did we got pretty close in our prediction to the truth. And so the truth, again, is shown in the middle. So this means that the transported predictions are similar to the true observed ones, which means that using population composition, we can in fact predict the effect for LA, which means that this effect anyway is transportable. And that the differences that we saw between Boston and LA can be largely explained by differences in the composition between those two cities. So we did this for some other risk behavior outcomes. Marijuana use is one. So this is the same setup using Boston and LA, and the transported effects are the dashed lines. And so we see that, again, using these differences in composition, we're able to bring that point estimate from Boston close to the observed point estimate in LA. So we don't get all the way there, but we're getting in the right direction. Similarly, for behavioral problems, we're bringing that point estimate from New York City closer to the point estimate in LA, meaning that for these two outcomes anyway, compositional differences can partially explain these overall site differences. Now, this wasn't always the case. We did this for a couple of mental health outcomes that we found weren't transportable, actually. So major depressive disorder, we didn't explain any of the site differences. And generalized anxiety disorder, I didn't talk about the assumptions required for this, but one assumption is a common outcome model across sites. We actually had evidence against that for this particular outcome, so we couldn't move ahead with transporting it. So one can ask, is it still useful? I think yes, because now I talked before about how previously we were using mostly opinion to say, are we going to assume the same effects across sites or different effects? So in this case, we are using evidence, and we're saying we're coming down on the side of, okay, let's do site-specific effects. Let's assume different effects across sites. So thank you very much. I'm showing the funding for this work and then collaborators on this particular work.